Okay, well, it's good to be here today. I'm excited to be with you. Like Jim said, my name is Parker Ericson. This is my first time presenting at the .NET Engineering Forum, so I'm excited for that. I've been on the Stack team for about 6 months now. And like mentioned before, there's lots of donuts. Donuts make you code better, so if you need an extra boost, get an extra donut back there. I wanted to start out today by just putting a little plug in for Integration Point here. Integration Point is where we as a Stack team like to keep information about Stack code, but also just different .NET related things. So if you go to Integration Point, you can get there by just typing in IP / and it'll take you right there. You can go to stacks.net. And then I wanted to point out today that we have Tony put up his engineering forum from last month here in December. And being in December, there were tons of people there, so if you missed it, this is a great place to go through and learn some new things and even watch Tony's presentation from last month. But overall, Integration Point.
Yeah, Tom, so you need to watch that, Tom. And then I want to report.
Okay.
A report for Tony. But integration is a great place to get information like that. And even it's on the featured list right there, Tony's engineering forum, if you're looking for it real quick. Let's see.
Actually, that one's from November of 2016. But
Oh, is it?
It'll get you to the right.
It'll get you in the right place. Okay, another thing that I'd like to talk about a little bit before I jump into the main part of my presentation today is our Advanced ASP.NET Core training that we'll be having this year. I just put up a list here of some of the topics that we'll be focusing on for that training. We're currently developing it now, but we wanted to put these topics up here for any feedback that you might have. This training will be a continuation of the boot camp training that Tony and Jim did previously, where we make a meeting program application. So we'll be continuing on that, building on to the meeting program app and making it so it's ready for release.
Can I just ask, how many people attended the .NET Core Bootcamp? How many people attended that class? It was a 3-day class. If you weren't able to attend, it is available on Integration Point, and you can go through the whole class. It steps you through it and gives you all the assignments and the instruction you need.
So we wanted to ask you guys for feedback right now. If you have any of this list of things here, are there any things that you feel that are missing or things that you'd be particularly interested in learning from this list?
A lot of people have asked about OAuth. We are addressing that.
I'd like to see maybe a little training in the new HTTP client factory.
Okay, excellent. We are planning on including that. That probably falls under the upgrade to 2.1, 2.2, but we will be hitting that, the client factory. Excellent, thank you. Did you have something back there?
I just said it looked like a good list.
Okay, excellent. If there's something that comes to mind that you'd like us to include in this training, let us know. Again, we're always open to feedback, and ultimately we want to help you guys as developers. Okay, so who here has ever traveled internationally before? Okay, so if you've traveled internationally, or maybe even not, you're familiar with a problem that occurs pretty much anywhere you go, and that is electricity. So we in the United States, we use kind of the type A, type B electrical outlets, right? But electricity is something that's needed all around the world, but you're going to be unsuccessful if you try and use a type A or type B outlet in different parts of the world. But there is a solution to that, and that is a universal adapter like this. It helps you, it kind of abstracts away the complexity, helps you plug into any different type of outlet pretty easily to get that source that you need, the electricity. So today I'll be talking about something that kind of helps us in the same way in .NET, and that is LINQ. So LINQ stands for Language Integrated Query. This is something that's pretty fundamental to .NET and developing in C#, and it's something that really makes developing in C# beautiful to me. So this is the Microsoft definition. Language Integrated Query is the name for a set of technologies based on the integration of query capabilities directly into the C# language. Or in other simplified terms, it's a way to express queries in C#. So LINQ offers a consistent model for working with data across various kinds of data sources and formats. So kind of like that universal plugin, it allows us to work with lots of different sources and formats of outlets to be able to query and get data, that information source that we all need into our code. So how does LINQ benefit us? Here are a few things. One, it helps simplify and beautify our code. Two, it offers IntelliSense for our queries. And with that, it helps us debug. It helps us find problems with our queries faster and at compile time. And then fourth here, it offers a common syntax for different data sources like XML or SQL or even just objects in your code. So we're going to get into some more advanced stuff, but I wanted to start with the basics, the fundamentals, and build on that. So,
Do you want to ask how many people use LINQ?
oh, that'd be good. So who here uses LINQ on a daily basis? Who feels like they have a really good handle on LINQ, like they're a master of LINQ? I know for me, I felt like I knew the basic things pretty well, and I used the basic things a lot, but I didn't know some of these advanced, or maybe even not so much advanced, but unknown hidden gems. So I'll be hitting on a few of those today. So here are the basics. Basically, you obtain a data source in some way, you create a query, and then you execute the query. So here's a bit of code that shows how to do that. We got our numbers. It's just an array of numbers. And then we have a query, which is of type INumerable. And here's our query there. And then we execute that query in a for each statement. So that's pretty standard for a LINQ statement. The from clause specifies the data source. The where clause applies the filter. And then the select clause specifies the type of returned elements. And so the data source in LINQ, any type that's INumerable of T can be a data source. So it's any object that supports the generic INumerable of T. And then, let's see. So what we have here is what's called deferred execution in LINQ. So we make the query, but we don't execute it right away. We wait until a later time. And then in this for each that's where we actually execute it. Because the query variable itself never holds the query results, we can actually execute this query as many times as we want. So if you're working with a changing data source, if you write this query and execute it, and then the data source changes and you execute it again, it'll get the latest data that you have. So like we see here, this is just simply getting even numbers from this list of numbers, and it'll output them like that. So what actually happens here, this syntax here is called the query syntax. Yes?
So a quick question with your last comment there, in the for each statement there, that means I would not be able to, or would be able to update num within the for each?
You know, that is a good question.
Is the definition of a for each?
That is a good question that I'm not sure that I have the answer to. So you're saying if you execute the query, are you able to update the data source?
Yeah, specifically for each loops don't let you update the value that they're tied to, right? So I'm just making sure that's still the case with LINQ.
That's a good question. Anyone shed any light on that for us?
It depends on the data source. If you're an entity framework, you can update it as you iterate through, but it's actually updating in a memory, and until you commit those changes back, it's not going to go back to the database to save them. If you're updating in memory, it kind of depends on what operation you're doing on them. There's different LINQ operations that are immutable, and then there are those that are mutable. So it really depends on which ones you're doing. So some make a copy of the source, like if you're modifying or if you're filtering down a subset of the source, then a lot of those are immutable, and you create a copy of the data set.
I think here the point is that the where clause is based on num. So if you change num within your for each, you've changed the criteria of whether that num should be returned.
So
So I think it's not going to let you.
Well, it will let you, but the difference is once you go into the for each loop, then there's deferred execution. Once it's executed that becomes an IEnumerable int. It's no longer a query at that point. It's just a list of numbers after the query is already executed. And as you for each through that list, you can do things that you can do with any list. It has nothing to do with the query at that point. The query is just the first step in getting you your results set back. Does that make sense?
I think there's some annotation you can put in the for each as well that will let you iterate and update. I've done that.
Interesting. That was a great question. Thank you for bringing that up. So, like I said, what we have here is called just basic query syntax in LINQ. But I'm sure that you're also familiar with method syntax. And what actually happens when you write it in query syntax, it'll actually compile down to method syntax. And we'll get to method syntax in just a little bit. But I wanted to hit on immediate execution first. So you don't always have to do deferred execution. There are some different methods that allow you to execute immediately on your query. And some examples of those are like sum, like we see here, different aggregate functions like that, like average or count. There's also different ones like toList or toArray. And then there's also ones that, like this, first or default. So these are all examples of immediate execution. And you'll notice that instead of returning an IEnumerable, they actually return an int or a list, like so. Okay, here's our method syntax. So these are those same queries that I showed before in LINQ, but just in method syntax. So method syntax just allows you to write it in method format. That's pretty straightforward. And one advantage of it is that you get a little more IntelliSense. So in some ways it is a little nicer because you get a little help writing your queries, but it does tend to get a little messier, a little faster when you're doing it this way. So it kind of begs the question, which syntax should I use, or which syntax is best to use? So we were kind of curious talking about this. Which syntax do you guys typically use? By a raise of hands, who typically uses the method syntax more often? And who uses the query syntax more often? Okay, interesting.
SQL guy?
That makes sense. The query syntax is very SQL-ish. So it kind of comes down to when should I use each syntax, because they both have their different advantages. So are there any people here that have a strong opinion about why or when to use either, or have a system for using both of these?
I just thought it was pretty much up to your personal preference, and you know, since I'm in code most of the time, I usually use the method syntax because it makes sense to me.
Right, definitely.
I wasn't aware there were actually like that many differences between them as far as the outcome. So.
And semantically, they're exactly the same. There really isn't much difference. It really is a preference of how you like to write your code. But the way you do write it can just make a difference for readability and that sort of thing. When I was talking about this with Tony shared a few rules of thumb with me. Tony, would you like to share a few of those that you kind of like to go by?
That was yesterday. I don't remember.
Okay.
What do we say?
Well, I think you were saying yesterday, Tony, that when you're getting into queries that are pretty complex, where you're having multiple for statements, multiple where statements, you have different methods and lots of garbage in there, sometimes it's nice to write it out in that query syntax just for readability. So if someone else comes along and is looking at your code, they'll understand what you're doing. I think sometimes it's easy to know what you're doing with your own method syntax, but if those get pretty verbose, it can be kind of hard to cipher through for other developers.
Particularly joins. If you ever do joins of a couple of different sets of enumerables, that's when the query syntax is a little easier to write the joins than it is to do it in the currying function type of or the method syntax.
Yeah. Thanks, Tony. Okay, so we're going to go through some examples, and for the examples, I'm going to use the example of just latter-day profits. So I have our latter-day profits object right here. And And we're going to go to the code and we're going to look at a list of these latter-day prophets, and we're going to practice our LINQ on them. So as you can see here, we just have a basic list of prophets. It's got their names, ordination date, their date of death, and their age. So we're going to practice a few things. Let's see. So the first thing that we're going to go through is we're going to look at multiple filters. So again, we have our data source right here. Now we need to make the query. So we're just going to do, let's see. Oh, looks like I have one running already. We're going to do IEnumerable of prophets, a prophet. And we're going to name that query. And so we just do our from for P and prophets. And what I'm going to show here is how you can do multiple where statements. That's one nice thing about LINQ is that you can do as many where statements as you want. So we're going to do a little trivia. So I'll extract this out of the data, but the question is, how many prophets were ordained during the 1900s? Who is the first and who is the last? So be thinking about that. So we need to put boundaries on where we want them. So we're going to say where P dot ordination is greater than new date time 1900 1 and we'll do where ordination is less than new date time. We'll do 1999 12/31. So any guesses here as to how many were ordained, or who is the first and who is the last? Anyone? Call them out. Nothing?
Was the last in the 1900s?
In the 1900s. Who was the last prophet ordained in the 1900s?
Hinckley?
How about the first? That one's a little more challenging.
Joseph Fielding Smith.
Okay, here we go. We'll see. Okay, so we have our multiple where clauses. Looks like I forgot to select there. Okay. So start this and see what happens. Okay, it looks like Joseph Fielding Smith. That was good. Who said that? I'm impressed. I wouldn't have been able to get that. And Gordon B. Hinckley. That was right. Okay, so there we go. We can do multiple where statements, which is pretty nice. It makes your code pretty easy to read. So unfortunately, you can't do this with or statements, which makes kind of sense. You can put these both on one line with an and statement, like that. But it is kind of nice to break out your code there. Okay, so you've probably noticed and kind of been probably a little bit bothered that I've been writing out all of these. One nice thing with LINQ is that we can use the var variable to really simplify things and make it a lot easier. So what we're going to do next, here's a little piece of trivia. Which three presidents of the church served longest? That's the question. Be thinking about that. And what we're going to do here is we're going to use an anonymous type. And we're going to calculate out how long each president served. So to make this go a little faster, I'm just going to go ahead and copy in some code. Let's see. Okay, so as you can see here, I replaced our IEnumerables with var. Let's see. I've got to change this real quick. Name last name. Let's see. First name. Okay, there we go. That should make it a little better. So what we're doing here is we are making an anonymous type in our selection. So we're creating a whole different type here. And in order to make that work here, we have to use the var, because otherwise our code won't know exactly what type of object will work here. Let's see. So we'll run that. Any guesses for the longest prophets who served?
Brigham Young.
Brigham Young?
David McKay.
David O. McKay?
Joseph Felix.
Joseph Fielding Smith? Okay. Okay, so this shows how long they served in terms of days. Brigham Young, obviously the longest. Heber J. Grant, did you say that, John? That was good. David O. McKay. Man, were you just looking at my data there? That was pretty good, John. I guess I shouldn't have made it so easy, but kudos for you guys for solving it pretty quick.
And one of the Joseph Smiths, one of them is the third.
Yeah. So this is pretty useful, especially when you're doing joins. You can do that anonymous type and really change your data into a model that works best for your code. The next thing that we're going to be looking at is just a basic order by. Let's see. So again, maybe for some simplicity, I'll just copy in this code. I guess you know what, we already did an order by right there. Order bys are pretty nice because they'll sort your code the way that you need it. Order bys are by default ascending, but you can also make them descending by just adding on descending right there. Let's see. And if you want to add additional things to order them by, then you can just here in the query syntax, then you can just add a comma and add on different things that you want to order it by, like last name if they serve the same data or whatever. Okay, the next thing that I want to talk about is grouping. So grouping in a lot of ways serves some of the same functions as ordering, but it is a little bit different. To do it, you have to in order to execute on your groups, you have to do some things different than you would normally. Let's see. Okay, so in this query, we're just going to, can people see that okay, by the way? Is that okay? Okay. So we're just going to group the prophets by their last name. So we're going to take the last name and the first letter of their name. But this isn't going to work right here because the return type for this, if you look, I don't know if you can see that, but it's an IEnumerable of I grouping. So what we end up having to do is a double for each to be able to execute on that. Oops, just a second. Which looks like this. So we for each on the group first, and then we can output the group key, which would be the last name letter. And then once we do that, then we can loop through the group and display the different members of that group. So if we run this, then we can see that work there. So like this, but we notice that it's not ordered correctly. So what we can do is add another order by, and then it will order these different groups into a nice, more understandable format. So all that we really have to do here is just add a order by, and then we can do the P. Let's see. Oh, what we have to do first, my mistake, is we have to put the group into a variable here. So we'll group by the last name into something we'll call P group, and then we can order by the key on key group. So P group key. and then we'll select the P group. So there, now we're all ordered out alphabetically. This makes it a little more readable. So you can do some pretty cool things with groups that enable you to break out your code. You can also use Booleans here in the group. So you could even say something like this. You could say, let me paste it in here. Oops. I've learned today that I'm not very good at pasting. So you could say group by and then do a Boolean expression. So group by the last name equals Smith. There are lots of prophets with the last name Smith. And then here you can see you can break out by true or false, and that's the key. So there are 4 prophets with the last name Smith, and then these are the others. The next thing that we're going to get into is joins. Joins are something that I don't use too frequently. Who uses joins on a regular basis in LINQ? Anyone? It's something that not too many people do, but it's a pretty useful tool as far as working with different data sources. So what we're going to do here is we're going to add in a new list here, and it will be, man, every time. Just trying to keep you guys on your toes here. We'll just add in a new object. It's a list of quotations. And each of these quotations has a prophet ID that they're associated with. So what we can do is we can join these 2 objects to be able to do some things in LINQ. So what we'll do now is we'll do an inner join. We'll do another anonymous statement here. Let's see. So what we have here, we do our from P and prophets like usual, and then we do our join. And you'll notice this is very SQL-ish. Join Q in quotes on the P ID, which equals the Q prophet ID. So that's very familiar for anyone that's ever done SQL. And then what we'll do is we'll create a new anonymous object with the name and then the quote there. And we'll get rid of this group executor. Man. We'll just output it like that. So that's a pretty easy way to combine objects and to make it into an object that's pretty manageable to work with, that suits your needs. That anonymous type combined with the join can be pretty powerful. Another thing that you can do is you can do something called a group join. And group joins are useful for producing hierarchical data structures. And it pairs each element from the first collection with a set of correlated elements from the second collection. And it looks pretty close to what we did before.
So can we pause there for a second?
Yes.
So is it line 72 where you do the select new?
Yes.
So you're creating a new object there, but that object type wasn't even defined before, was it?
Mm-mm.
That's cool.
Yeah, so that's called an anonymous type. Sorry, I probably blew through that a little bit fast, but yeah, that's not an object that a type that we've defined anywhere, but you can create your own new anonymous types right in your LINQ statements. And then, like I said, that's why it's really necessary to use this var statement down here and even up here so that we're able to, it makes it possible for us to even do that in C#, which is nice. Okay, so we're going to be doing a group join right here. And so basically what we're going to be changing is that we're just going to take this join and we're going to put it, let me stop that code, and we're going to put it into a group. We'll call it quote group. We'll keep our select statement the same, but again, this is going to make we're going to be forced to do that same thing that we did where we did a group by in the previous example. We'll have to do a double for each. Oops, let's see. So let's see. For each came. Oh, Q does not exist in the current context. Oh, okay. So we do have to change one thing here with the anonymous type. So instead of adding the quote directly, we're just going to add the whole group. So we'll just change this. Thank you, that was a good catch. We'll change this into that quote group that we created on the group join. There we go. That did it. Uh-oh, looks like we got another.
Well, just quote, I think, instead of.
Okay, good catch. Thank you very much. Okay, so you notice that they come out a little bit different this time. Now they're grouped by each profit. So it makes it a little easier to work with your data. It allows you to sort it out a little bit easier and work with it that way. So the group join is pretty useful as well. Let's see. So there's a lot more to learn about joins. You can go pretty deep into joins. You can also do outer joins, which Tony informed me were one of the hardest things to do in LINQ. So if you're feeling like you need a good challenging code project, you can tackle the outer join. I wasn't brave enough to do it myself. But we'll go ahead, we'll move on to another example. And we'll look at another data set that I have here. I was interested, we're going to look at the articles of faith this time. So the articles of faith, they're just a list of strings here. And what I'd like to demonstrate this time is how you're able to do multiple from statements in LINQ, which is pretty nice as well. So we'll do our query, and then we'll do from A and articles. And then we want to do, what I want to do here is be able to parse out every word from the articles of faith. Let's say that I want to see how many words, what are all the words that start with P, for example, in the articles of faith. So doing a query just on the articles isn't going to be good enough. I need to drill down a little deeper. So I'm going to do from word in, and then we're going to do a split here. And for this split, I'm going to pull in an array of delimiters to make this a little bit easier and cleaner. Man. And then we'll just plop that in here. Delimiter. Did I spell that right? There we go. Do the lazy approach. And then we can do something that I didn't know was possible until I did this example. And remove the empty entries from the split. And then we're just going to select the word here. So with LINQ, we're able to drill down a level deeper here with multiple from statements. And then we'll just pop that out here. Okay. So this will give us every word in the different articles of faith. And And there we go. But like I said, it would be nice if we could break it down a little bit further and maybe just get the words that start with P. So another thing that we can do with LINQ is we can actually declare variables within our query statement. So we can say let W equal, let's see, word, and then we'll just take that to lower. Oops. And then we can do another statement where we say, thanks, Tony. Always got my back. I know it is kind of weird going to a new line with that one. Where where the first word of the first letter is equal to P, and then we'll select the word. So this right here, like I said, it's nice. You're able to create your own variables right within your statements. And if we output this, then we'll get our list of words that start with P, including this one. I've heard it pronounced a million different ways in church every time. Does anyone know the right way? I've been curious about that. Paradicycle. Thank you, Michael. So I guess I have been saying it right, but I've heard it pronounced lots of different ways. So this is something that may not work in Entity Framework if you're using that let statement. So just be aware that if you're using Entity Framework LINQ, then that let statement might not work quite as expected. You might run into some bugs there. Let's see. I'm gonna hop back to my slideshow here. Okay, so this is one thing that I discovered as well in the course of making this presentation. Does anyone know the difference between these two lines of code here? I'll point out the difference, and then maybe you can tell me what makes them different. One of them's first or default on the end, and one of them's single or default.
The single's only expected to get one result back.
Yes, that's correct. So the
Repeat that answer.
Okay, he said that the single is only expected to get one result back. So that changes how these two work and how they perform. You had a hand there. Did I see an additional comment? Okay. So with single or default, like you said, it's only looking for one result. And in fact, because of that, it's a little less performant because it'll find the first result and then it will continue to loop through your data source until it finds a second one. And if it finds a second one, it'll throw an error. Whereas first or default is a little more performant because as soon as it finds the first one, it'll return that. So that is, if you're looking for more performant code or if you're looking for more explicit code, either of these could be a good option for you. LINQ also has a lot of useful set operations. A lot of these are pretty self-explanatory. Distinct basically turns your data source into a set where there's only distinct objects. The rest of these, except intersect and union, help you do things with multiple data sources. And these are really useful and pretty easy to use, and there's good documentation online for these. These next two were, to me, some of the hidden gems that I found out about LINQ, skip and take. So skip allows you to skip over a given number of elements in a sequence and then return the remainder. And then take returns a given number of elements and then it skips over that remainder. So here's a little example. So if we have a LINQ statement here that just gets the profits by last name in order, and we do a take 5, it'll only take the first 5 off that list, like displayed here in the bottom. But if we do a skip and then a take, it'll skip those first 5 in the list that we saw here, and it'll go to the next 5 in the result set. So that one's pretty handy. So that one's pretty handy if you're doing things like pagination or things like that. It makes it pretty easy. This is another probably hidden gem that I found in LINQ, something called zip. It applies a specified function to the corresponding elements of two sequences, producing a sequence of the results. That's a fancy way of saying it takes two data sets and allows you to smash them together. So a simple example right here, we have a list, an array of numbers, an array of more numbers, and with this zip statement here, we can essentially just combine them right here and create a new list of numbers. And then the last thing that I'm going to end on today is probably one of the more advanced topics of LINQ, which is called parallel LINQ. So parallel LINQ is the kind of self-explanatory, the parallel implementation of LINQ to objects. And it allows you to do parallel programming with LINQ. And it's actually fairly easy to implement. All that you have to do is smack a as parallel onto your query there. So just like this. But you'll notice that I have two different examples of how to do as parallel. One of them's good and one of them is bad. So parallel programming allows you to run some of your code simultaneously. But there can be circumstances where doing that in LINQ actually will slow you down. So if you're doing a simple operation, kind of like on the bottom, where you're just checking to see if the number's even or not, that will actually result in a slower time than just doing it without as parallel. But if you're doing an expensive function, like up top, some expensive function, that's a lot better for LINQ, and that will increase your performance by quite a bit. This is something that I am not going to go too in depth with today, but if you're interested, I showed a link here on the bottom. This is where I got that example, but there's a lot of good documentation online from Microsoft of how to do that. Looks like I may not have quite enough time to do this. Another really useful thing that you can do with LINQ is query XML. I was working on a project not too long ago where I think I was getting data from the eBay API. And eBay, the JSON that they sent me back was just horrendous, but their XML looked kind of manageable. So I used LINQ to XML, and it was pretty easy to parse out data and to get exactly what I needed. So I'd encourage looking into that as well, the LINQ to XML, if you work with XML very often. But this is all that I have today about LINQ. I hope that it's been helpful in some way, shape, or form. LINQ is it's a fundamental of C#, and you can do a lot of things with it. And I'd encourage you to even look for more things that you can do with it. Look through the documentation online and look at some of the other, maybe more unknown functions of LINQ. Are there any questions or comments? Awesome. Thank you so much.